Hello. Today I'm going to demonstrate how to build a battery interrupter. But first I'll explain what that is. A battery interrupter is a device that allows you to use a switch with any electronic object that is powered by batteries and is normally in an always on or off state. Think of like a fan or a light. In this case, we have this nifty toy that flings the string around all the time. And you can just turn it on and have it on or turn it off. So a battery interrupter looks like these guys right here. At one end, you have a disc or plate that has metal on both sides, but is interrupted with something that does not conduct electricity. And then there is a two-conductor cable wire connected, one wire on each side of the plate, that leads up to a female jack at the other end. This is 1/8 inch or 3.5 millimeter, which is the standard size for ability switches used by folks with physical disabilities. These come in a variety of sizes. This one here, you can tell it's designed for C or D size batteries. You can see right there it's about 1 inch exactly. The smaller guy you would use with a toy like this one that has AA batteries. And the way you use it is the plate is slid in between the end of the battery housing and where the battery would go. And then now it's interrupted. And now, when the toy is turned on, it doesn't do anything. However, if you plug your ability switch into the end of the jack, we can see when I tap the switch, the toy activates. And that's how a battery interrupter works. Okay, now let's see how we can make our own. And it's pretty darn easy. That's the biggest benefit of this adaptation, is it's very easy to do, and it's very cheap as well. So let's dig in. First of all, the only things you need are a little bit of two-conductor wire, some copper tape, it's got adhesive on the back, a 1/8 inch or 3.5 millimeter female jack, a little bit of shrink tubing, and a non-conductive firm material to be sandwiched between the two layers of copper tape. In this case, what I've done is I cut up used gift cards. It's a great way to recycle your old gift cards. They're nice and thin, yet sturdy, and you can cut it to whatever size you need depending on the kind of batteries you want to interrupt. So that's what we've got here. And then your basic soldering tools that we'll be using today. So another recycling thing that I'm going to do today is I had some old cables that I did not need in the configuration that they were in. And this is, again, a two-conductor cable, and at the one end it had a 3.5 millimeter jack. So this is all pre-done, and I can't remember what was at the other end, but it was something that I did not need anymore. And so I just clipped off the other end, and I'm going to repurpose this for our battery interrupter. So in today's video, I'm not going to have to go through the whole process of soldering on the female jack onto here because we've already got something that will work great. However, let me explain a couple things about this process and what's ideal for a battery interrupter. A lot of this is from experience, learning what's the best and least effective ways. First of all, your jack. If it happens to be a mono jack with only 2 ports in here for you to solder onto, great, super easy. A lot of them, though, are gonna look like this, where it's more like a stereo. There's 2, and then the longer post. And so what you want to do is you're going to solder one wire onto one of these terminals, and the other wire actually needs to cross both of the other 2 to make sure you're going to have a solid connection all the time. Unfortunately, it's not always the same layout, but I have found that most of the time this port that, if you're looking at it from where all the terminals are, it's on the left side, is the one that should be by itself most of the time. And these other 2, the long one and the one on the right, are the ones that need to be connected off the same wire. All right. Also, if you're building your own cable with the connector on the end, that's another time where you would want to have plenty of shrink tubing to reinforce where you've soldered, because most of the time, unfortunately, people pull on the cable, and if it's not well reinforced, then it's pulling pretty much right off the soldered joints, and things can break easily. So by using a little shrink tubing, that can be reinforced there. And you might even, after you assemble everything and solder it together, you might even put a zip tie around this joint right here to really reinforce everything. All right. The other thing to note when making a battery interrupter, the cable end does not need to be very long at all, because it just needs to be long enough really to just stick outside of the toy, and then you're going to plug your switch into there, which has its own cable. The other thing is that this can be a very weak point where these are soldered onto the plate. You know, then because this is then shoved into the battery compartment, toys move around a lot, things can just get kind of weak as they're bending around a lot. So this particular cable that I picked out here has 2 solid copper wires there that are going to tend to be a little stronger in this specific application, and I found work out really well. So that's what I try to go to when I'm making a battery interrupter specifically. Okay, so we're moving on. So in this lovely recycling example, one of our ends is already done, saves us a lot of work. We're going to prep the other end of our cable so that we can add the actual battery interrupter plate. To do this, I'm going to use my handy dandy X-Acto knife to split down the middle between the 2 wires. All right, go down, I might go down like 1.5 inches, and then I want to carefully strip back some of the external housing protection. I would say about 1 centimeter. Okay, with my wire strippers here. You will notice as you're dealing with lots of different wire, cable, there's quite a bit of difference in the strength and durability of different types of wire. So this here is 20, I believe this looks like a 22 gauge wire. And that means collectively all these little strands, the thickness that we get. And that's about what I would want for my battery interrupter. 20 gauge might work. It's going to be a little less strong, I think, but this is nice here. Okay. So you saw I peeled off about 1 centimeter of the outer housing from the cable, and I twisted up the copper strands. Now I'm going to do what they call pre-tinning. I'm going to pre-tin these copper strands here. It's going to make it a little more effective when I connect everything in a little bit. Here's my hot soldering iron. I'm going to apply a little bit of solder on the end there. The heat conducts much better if you are conducting solder to solder. So now let's see. I'm going to apply heat to one side, bring the solder from the other. There we go. You can see it soaking up. Like that. Do the same over here. Great. Okay. Now that cable is ready to go. The other thing I'm going to do at this point is slide on my shrink tubing. If I don't remember to do it now and I begin to solder my different pieces together, it's going to be too late later on, and I'm going to be stuck. So always, and this is super easy to forget. So try your best to really recall, oh yeah, I've got to take care of my shrink tubing. So I've got one larger diameter piece that goes on first because that's going to in the end be the outer layer. I've got two smaller diameter pieces of shrink tubing that I want that are going to be for each of these individual wires. And you can see there I've got a good amount of space between where my bare wire is and my shrink tubing. You want that because if I start soldering and this is too close like this, the heat's going to transfer and it's going to start to shrink up my shrink tubing before it's in place, and that will be a problem for me. So that looks a little better. Okay, now my cable is all ready to go. Time to prep my plate. So the easiest way to do this is to cut your tape about a little bit bigger than the size you want. You want the tape to come really pretty much close right up to the edge without hanging over, having extra hanging over, because if your tape goes over the sides of your plate, then there's that possibility that it could touch the tape on the other side, and then you have a short, and your battery interrupter is not going to work for you. So there I just peeled off the paper backing from my copper tape. I'm going to lay it down here on my work area, if I can get off my fingers. Okay, now I'm going to do my best to lay down, there we go, the piece of credit card, gift card that I cut out. And we can see that there's extra tape around the borders, and that's just fine. That's where my X-Acto knife comes into play. I'm going to cut as close as I can right on the edge so I can cut off that extra. And notice when I cut out my piece of gift card, I trimmed back the corners too. See that? That just makes it much easier and better to fit inside of the battery compartments. If you have those pointy corners sticking out, it's a lot harder to get them to fit into those battery compartments effectively. Okay, let's take a look at this first side. You can see, pretty nice. Covers pretty much the whole side, nice and shiny, but it doesn't go past the edge. That's a nice job there. Okay, one more side to do. And this copper tape, it's not really all that expensive. So, you know, you don't have to worry about, oh, I'm wasting or I have to redo that. It's really not that expensive of a material to purchase and work with. Okay. There we go. Trim up this side. Just make sure you get right along the edge. There we go. Okay, let's take a look here. Nice and clean. Now, I don't know if you can see this on the camera. Right here, there is a little extra that's folded over the side. So I'm gonna recut that with my blade, so there's no chance of having a short. Okay. I'll look again. That's better. Great. Okay. Now that's ready for us to use. Okay. I'm going to bring in my handy dandy alligator clip arms. Bringing one down here to hold my plate right at the corner. And what I'm going to do in this case is to have a really strong connection here. I'm going to put a nice big blob of solder directly onto the copper here, the copper tape. I'm going to later add my wire onto here, so I don't want to leave the heat on here very long at all, so I can then heat it up again momentarily in a little bit without having overheated the solder too much. So, but it's going to go real fast on this copper tape. There, you see there's a nice big blob on there. That'll work just fine. And I say blob, and relatively speaking it is, but it's also not out of control, I guess is the best way to say it. You'll notice this grabs the heat real fast, so you also don't want to heat it up too long so that your credit card begins to melt all over the place and warp. So in this project, judicious application of heat. Okay, great. Oops, like I said, hot. Okay, so, and again, after applying the heat, I'm gonna look at my edges again, make sure I haven't created a problem for myself. It looks okay. Maybe just give it a moment to cool down a little bit. Now, also, one thing that's helpful, I'll bring in this other battery interrupter. You'll notice the wires on this one, they're pretty at the corner. That's because when you go to place the battery interrupter into the battery compartment. Now you can see the cables end up being at the corner of the compartment, right? Which makes it real easy to manage it with, I put my outer plate back on and I've cut the corner away from this plate so that there's a spot for the cables to come out. All right? That's the reason that is configured that way. So I'm going to be looking to do that to some degree with this one as well. Okay, so there's our plate. Bring my other arm in here. Again, making sure my shrink tubing is back well enough. Okay, so now I'm going to bring my wire that's going to connect to rest right on that plate. And since I already have on my solder both on the wire and on the plate, I've got an extra hand. I can hold everything in place real well so that I can be real quick and effective. And notice also the rubber where the wire is exposed and then protected by the outer covering, that should go right up to the edge of the plate, again to minimize the possibility of having a short with the two wires being able to touch each other. Okay, so now I'm going to briefly heat up this solder again that's on the plate and the wire, and they will connect real quickly. And you also are trying to keep this as flat as possible, okay? If you aren't able to have a nice flat, and I could have done that a little bit better. Hang on a second. If you aren't able to have a nice flat merger of these, then it's going to be harder to get it to work effectively in the battery compartment. Let's try that one more time. A little bit better. Okay, let's get this last one in done. Oops. And then also, you can see as I am connecting these wires, I am having a slight gap horizontally of where they meet on the plate, again, so that they are not likely to touch each other. Okay. You can see, even being pretty careful, the card wants to bend and flex a little bit pretty fast. So yeah, you gotta be, that's probably the trickiest part, is just not keeping your heat on there too long. So that side, nice and flat. This one, it's actually not too bad, especially because I've got it right in the corner. So now I'm going to bring my shrink tubing. Let's get these arms out of the way. Bring my shrink tubing right up to the edge, like so. Bring my flame. You don't have to put the flame directly on the tubing. Just get that heat in there somewhat close and be a little bit patient, and it'll shrink up for you. Especially with the cheaper shrink tubing, if you overheat it, it will split on you, and then didn't work so well. That wasn't too bad. All right. And one more layer here, right, to make everything as sturdy as possible. You're kind of balancing between having something that's strong and sturdy, but also you got to be careful about it getting too thick, because then it's going to be hard again to get it to fit into a battery compartment and work where you want it to work. So it's kind of a balancing act between those two things. Okay, so we're about done here. You can see what I have, to me, looks to be effective. We recycled this end, looks great. We made our plate, connected our wires. There doesn't appear to be any crossing over anywhere. It's relatively flat. I know it's a little bit bunged up, but it's pretty much flat. Solid connections on my wires with the solder onto the plate. Nice and shiny, so it's not cold soldered, so it should conduct electricity well. Okay, so now we want to test it out and see how well it's working. Just a moment here. So I'm gonna remove my battery. Okay, now I've got my plate, and the orientation I would want is like this, so that my cable will come out the corner of the box. Okay, so I've got it, the plate in between the spring and where the battery goes. And I like to do that end because that means the very flat end of the battery is next to the plate, and that's going to make it a lot easier to place everything. There, we can see that that's seated well. Okay, let's go ahead and try the whole thing. I'm gonna put my plate, my outer plate, back in here. Okay, and screw it down. Okay, so that fits. There's my string thing. Great toy, by the way. Okay, I have my homemade switch for my test. The last thing to do is to make sure that you put your toy in the on position. So that's great right away that I turned the toy on, but it did not start activating before I hit my switch. If it had, that would be a clear sign that I have a short, that my plates, the metal from the two sides of the plate, are touching somewhere. So since that did not happen, we're probably in good shape. We'll see here as I touch the switch now. There we go. Success. We have a functioning battery interrupter. All right. And that's all there is to it. Finally, battery interrupters, again, explain how they're a nice, easy way to adapt some types of toys and items like fans and lights. Also, as you saw, they're pretty cheap too, and can be quick to make after you've made a few. If they do get damaged or broken, it's not too big a deal at all to fix it or replace it. All right, thank you very much.